All right. Oh my god, I hate doing this. All right, so thank you everyone for joining. We're going to cover seed phrases and the Mandala Network. So, uh, seed phrases were invented with this thing called BIP39, and BIP39 was a way to have seed phrase 12 words used to restore a Bitcoin wallet. So a Bitcoin wallet uh, works generally where you don't have just one private key. Right. So Satoshi Nakamoto had mentioned a long time ago that uh, Bitcoin wallets, you should not reuse keys. So in order to not reuse keys, what we should be doing is having a new key used for every single transaction. Well, this introduces a problem where if you're just a regular old user, how are you going to remember um, 1,000 different private keys, strings, or anything like that, right? So it doesn't make any sense. So what did we do? Someone really smart came up with the idea. I should forget who came up with this. Came up with the idea of having 12 words that could deterministically generate all of the private keys for a derived master private key. So what that means is that all you really needed is a way to derive the original master private key, and then you could derive all of the keys from there quite easily. This was a really awesome invention, right? It allowed people like people that aren't familiar with computers to be able to store Bitcoin securely. But so how does this work in practice? What this means is that if, for example, I enter these 12 words, let's say I have my Money Button wallet and I want to move, export my wallet into a new wallet. Well, if I enter these 12 words, now the wallet that I'm importing these words into has to scan the blockchain, derive all these different keys, and check to see, does that address have a UTXO? Does this next address have a UTXO? If any of you actually remember when Handcash, I think, went out of beta, this was a really big problem because people were importing their 12 words into like Electrum SV or things like that, and then they weren't finding any of their coins, and that's because they weren't actually scanning enough addresses to find all the coins that were theirs. So this became a problem for people at that time, but no one really kind of stepped to think through, well, what's going to happen when blocks are really big? And for example, I have a wallet that I've been using for 30 years, right? A wallet that's used daily for 30 years is not going to be pretty easy to import those 12 words and then scan the blockchain across 30 years to get a valid UTXO index. So, cool. Seed phrases were great, amazing. You can Google them. BIP39, the wiki, the Bitcoin SV wiki has some good information on this as well. So Roger Taylor from Electrum SV made quite a stink when he brought up that the need to support addresses in general. He kind of looped a few things together. Number one, the need to support addresses in general, the need to support seed phrase recovery, which again, if you're going to say you're not going to support seed phrase recovery, that's kind of like heresy in the Bitcoin world, right? But I think he has some pretty good reasonings for what he's talking about, but maybe we can just break it down a little easily and kind of go over it. So first, let me talk about addresses, right? Number one, what is a regular Bitcoin transaction that we're used to, like in the white paper behind me? It is a pay to public key hash transaction. What that means is that I ask you for your address, I send coins to the address, and now you have money. This is what has been historically called a standard Bitcoin transaction, and this was determined, quote unquote, standard by Bitcoin Core, but probably for a pretty good reason. Like in the white paper, we define a pay to public key transaction, and an address is a hash of a public key. So probably, for good reason. Why is that common? Well, the white paper pretty much told you how to send coins to each other in this manner. So this format of sending coins meant that there are a few different ways for us to move forward when you're building wallets and things like that. And the first is that, okay, if coins are getting sent to addresses, and we have ways to generate deterministically almost an infinite amount of addresses given one master private key, that means that if I want all of the UTXOs for your wallet, a wallet could scan all of the addresses in use by your wallet and get all of the unspent transaction outputs. This is really good. It's useful. This is how our wallets work today, but it's pretty not ideal, and I'm going to talk about that in a second. But first, we have to familiarize you with the concept of what a non-standard transaction is. So I've mentioned a standard transaction as pay-to-public key hash. A non-standard transaction is any way of locking up Bitcoins without going through this process of, given an address, I lock coins to that address, and the only way to spend the coins is to provide the corresponding private key to that address. Give me 1 second. I apologize. I'm just going to... Okay, so a non-standard transaction is going to be any transaction that locks coins up not in this manner. So really all a Bitcoin transaction is you have a locking script and you have an unlocking script. I apologize for my dogs. What that means is I'm not necessarily limited to locking coins to an address. I can lock coins to a math problem, for example. There's a way that I could create a Bitcoin transaction that says, what is 2 plus 2? And in order to spend the coins, I have to provide the solution for. This is not impossible to do. In fact, it would be quite easy to create a script like that. It means that I can have way more complicated scripts, which I can cover a little bit. So non-standard scripts can be as simple as 2 plus 2, but they can also be as complicated as, for example, R puzzles, which we're not going to cover too much in depth. But what that means is that this way of looking up UTXOs actually becomes not valid for these types of scripts. I can't just do a UTXO lookup on addresses if I let's say, for example, I lock coins into a script. Let's say it is an R puzzle script. You don't have to be familiar with that. But essentially, I'm locking coins into a script that is not as simple as providing a private key to spend the coins, which means that, and it's also, the coins aren't being locked up into an address, which means that if I'm a wallet, I can't just get a UTXO by looking up the address because there is no address for that type of script. Let's just go over here. So now he kind of goes through the idea of like, why are we doing everything this way? Why has it been done this way? And how are we going to receive payments to addresses? So for example, let's say I have a wallet that's been in use for 30 years, and I have an address that was generated 30 years ago. If a payment is sent to that address, that means that the wallet, in this case Electrum SV, will need to scan the whole blockchain, finding that a payment was sent to that address for your wallet, and now recognizing any transaction outputs that are now valid to be spent. He says that this is too costly because them as Electrum SV are not going to run a node to do all this. They're not going to be able to scan the blockchain themselves and do all these types of things. So this created sparked a hullabaloo, so to speak, because he had this other Twitter thread in October that mentioned seed phrases and basically said that Electrum SV was not going to support seed-based restoration for this exact reason. The ability to just generate 100,000 keys and then have to rely on the wallet to be able to scan the blockchain and manage these keys is really not feasible. Okay, so hopefully all of this makes sense to you right now, because now we're going to dive in a little bit further and talk about what's the solution. So really, Roger doesn't actually provide a solution for us. He basically just says they're going to handle it a different way. I think he's written articles about their plans, and I apologize, I actually haven't taken a look at those. But the thing he mentions at the end is basically that if you can find a wallet that promises seed words will always work the way you've used them in the past, I'd be very surprised. That's because, like I just laid out to you, as non-standard scripts become the norm, wallets are not going to be able to do this. This just isn't going to be the way wallets work anymore. In fact, I would be surprised if pay-to-public key hash is the dominant transaction type in the future. While it is right now, there's other better ways of doing that. But this problem is not really that big of a problem to you as the user because we have solutions in the form of market forces. And what I mean by that is something that really has not been explored much is when Craig had mentioned a really long time ago this idea of a Mandala Network, which actually the cool thing is, this might just be Google featuring this because I look at BSV related stuff all the time. But when I Google Mandala Network, this is actually what comes up, the Bitcoin SV wiki itself. So the Mandala Network is this concept. I'm trying to find actually a picture that would be better. That you have a tight central core, and then you have layers like an onion outside of it, and then that onion provides new layers, and eventually there's really no limit to the number of layers, I think, but I think most of these images cover 3 or 4. So if we keep, in the instance of Bitcoin, we have the miners in the middle, and then we have these things outside of it. But right now, Bitcoin really isn't operating that way. We have the miners essentially handling everything. We have wallets that are kind of like right here, if they're probably running their own node just by necessity right now, because that's the way that a lot of legacy infrastructure works. And then really there's nothing else. Really there's just users at that point. We really don't have SPV in use that much right now. It's all kind of like this quasi, everyone's still running a node type thing to get stuff done. There's really no reason to be doing it that way, but that is the way that it's working. And this means that if I'm a user and I take what Roger is mentioning to heart, there's really no good way to refute his point because if Roger has to run a node to scan the blockchain for addresses, and miners are the only ones that really should be running nodes because they're the only ones that have the financial incentive to do so, then this probably looks all messed up. But the one thing that we haven't talked about in Bitcoin SV nearly enough is the layers that will exist outside of miners. So for example, and Roger actually does touch on it in his thread, this archival search engine. So where this is going to end up, and the reason why I never, ever really get that concerned when people start talking about data pruning in the blockchain or things like that, is that we have yet to see these outer layers of the Mandala Network form, and those are going to be the ones that actually provide these services. If I'm a miner, I actually have the ability to prune every single thing in the blockchain outside of the UTXO set and the hashes of all the blocks. There's really nothing that guarantees that when you create a Bitcoin transaction, you can, and let's say you add data to it in the form of op return, or even push data for that matter, not just op return, that you'll be able to retrieve that in the future. There's zero guarantee of it. It's very unlikely to be true if smart miners are just going to say, which by the way, this is also covered in the white paper in section 9, I believe. I don't know, maybe that's SPV. Section 8, reclaiming disk space, where he basically, Satoshi outlines basically, there's no reason to keep the blockchain, just keep the hashes. Once you're pretty certain you're on the longest chain, just keep the hashes, and you don't have to worry about dealing with the rest of the crap. So the reason why this is going to form differently is that what you're going to actually end up with is that the data element of transactions are going to be offloaded to new layers. So if, for example, you want to provide seed-based restoration, you're going to set up a node that, given an XPub, will search the blockchain for all the valid UTXOs for that seed phrase. There are going to be services that provide this, but it's just not going to be free. And that's kind of what Roger's whole point is that he's not going to be able to provide this for free to you because he's not going to be the one running the node to do it. Although I would argue, though this is a business opportunity for Electrum SV, but I think his point is that seed phrases aren't really going to be the way that this works anyway, because probably pay-to-public key hash is not going to be the way that Bitcoins are moved in the future by majority. There's really no reason for address-based... Okay, I have good comments here. I'll get to that in a second. But address-based transactions probably, in my opinion, aren't going to be they might still be in use, but there's really no reason for them to be the majority transaction type once you kind of look into to better uses with ECSA and non-standard transactions. So I'm gonna cover actually someone who probably knows a little bit more about this than me. But so Dean is in the comment section saying the idea that seed phrases won't scale or unfeasible long term is like saying in the future people will no longer be interested in recovering $1,000 for $10. I quite agree with that. That's kind of what I was getting at. This is further compounded by the fact that gigamegs of dog.jpg do absolutely nothing to bloat the UTXO set. UTXO set is like around 10 gigabytes or something. I can fit that on a thumb drive. A pruned node can actually handle this service. So a couple things to cover here. So first, completely correct, right? So shoving a ton of crap into op-return does not bloat the UTXO set. As we're talking about, the size of the blockchain really isn't that related to this problem necessarily, assuming that the majority of the size of the blockchain is, extraneous data that can be pruned from the transaction, right? So an op-return type transaction, we can just throw all the op-return crap out of the way. We don't really care about it. This would become a little bit more complicated if it shouldn't be, but as of today, it would be. If, for example, I'm putting a ton of push data in, let's say I have a pay-to-public key hash script, but I have a ton of other push data stuff in it, I would actually doubt that existing infrastructure would be able to recognize that to do a UTXO lookup in that address, for example, and things like that. But right now, the UTXO set is something like 10 gigabytes. That's probably true. But I think that is a little separate from the issue, right? So if I have an XPub or this master private key, for example, and I want a way to restore all of that going back, let's say 30 years, it will require something to scan across the 30-year history to be up to date with the UTXO set. So there will have to be some amount of checking across those things. But like you're saying, that kind of service is going to happen no matter what. If I'm not going to spend $10 to restore a seed phrase that I'm pretty sure has no money on it, for example. Now, if that seed phrase is a Bitcoin wallet that I bought a Bitcoin in 2011 and now it's 2050 and I want to crack it open, well, there will be a service to provide. Sorry, I'm reading comments while I'm doing this. There will be undoubtedly services to provide that, but you're just going to have to pay for it. I think that was all really Roger was getting at here, which is that I even said here there's nuance to this. I won't get into these tweets. And Dean is saying only if I want history, but we always want history. I think that actually is the argument. You're always going to want history. If I look at a transaction, if I want to restore my seed phrase, for example, we always want history. There's always going to be a necessary amount of history that I need with that. I'd be very shocked, for example, if I just give a seed phrase and then spend coins and don't ever have to care about the history, especially if it's a Bitcoin that went up in value for 50 years. You're probably going to need some amount of history with that. But I actually think there are, again, other solutions to this. The wallet can actually store data offline when it makes these transactions at the time. Right, so I could have software right now that actually stores a ton of information about the transactions I already have, and then in 50 years, if I do a seed-based recovery, I can probably combine those things together anyway. So that problem is actually probably moot too, as long as we build better systems in place right now. I actually think that's the way that applications should really, if you're an application that, let's say, generates your own transactions, there's no reason not to store an entire offline, database of the transactions, and you can even add metadata to the transactions themselves to use it at a later time, right? That also to me is a very simple and efficient way of doing having transaction backups, I guess, alongside your seed phrase. Okay, so let me just go back to this Mandala Network issue, because again, I think this is something that needs to probably emerge sooner than later. It's something that we're working on, definitely. It's still not something that is happening. Essentially, we're relying on the center of the network to do everything, and that's really dumb. For a few reasons, because it's giving a false impression that, number one, if I build an application that just shoves a ton of crap in an op return, it's for some reason now an immutable database, and blah 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 blah. It's really not true, and it won't be true for long. I would imagine it's not going to be true for in a year from now, because there's really no reason for miners to keep 10 gigabytes of dog JPEGs, for example. In fact, I don't know why they're doing it right now. So what we're going to actually end up wanting to see is, if you look at this circle here and then the shell of circles around it, what we're going to want to start seeing, so take the colors here, we have purple, green, blue, and pink. What we can actually start to imagine is, for example, maybe miners offering different services, right? So miners could be offering different types of services where maybe the green miner does keep an entire history of the blockchain, but maybe to collect data, maybe they offload all of the op return data processing to a layer outside of it, and if I want any op return data, I have to go to that node in the network to retrieve op return information, but I'm probably going to have to pay for it. And maybe that node is locked into a smart contract with the miner to do some kind of SPV check and things like that, so that we can be certain of the validity of the transaction and all that kind of stuff, and have integrity in the data. But then maybe, for example, different nodes in the network will have different timestamped records, right? So what we're actually sort of seeing is a filtering of information, but all of it still connected to the core. So using SPV, we can have some kind of certainty of the validity of transactions, but we don't actually have to start storing all the transactions and having one giant global database lookup. We can actually have database lookups according to specialized nodes in the network. So, for example, in my opinion, let's say if I were to take the Bitcoin network as it is today and try and break this up into a Mandala network that's actually usable and not just relying on like 5 nodes in the network to query everything, I would have users on the outside. Those are just regular people that use wallets. I'd probably have the wallets next on the inside, which are the ones that are really right now probably running nodes. I think Handcash says they don't run a node. They do everything peer-to-peer. I'm sure they just offload all that to the miner. But for example, someone like an Electrum SV is essentially running a server that takes the whole blockchain. And then in the middle we have the miners, and all of the data is essentially being shared across all these things, and then we have to query everything all at one time. What we need to start doing is actually having, for example, Twetch should have their share of the Mandala network. Our application should have their share of the network. All these different types of things need to start merging, where I don't actually care about Twetch's transactions. I don't care about Tonic Pow's transactions. I don't care about any of these other things unless I'm building something with them, in which case I would share it with them in the network. So I'm going to stop there. I don't even know if any of that made sense there towards the end, but we're going to stop. I'm trying to get back into creating some kind of content in some way, shape, or form. This one, I was way off my game because the first one I screwed up the whole stream. So we're going to keep streaming. If you want to do the streams with me, have conversations about educational topics, let me know. We will cover it. And I will fix all of the technical issues moving forward, and I'll stop it there. Thanks.